All right. Well, today is Friday, May 19th, and we are going to be talking a little bit about serverless building and Stitch It on the DevOps Decrypted podcast. So, welcome. I'm your host, Laura, and we have with us Jobin and John and Erico from Stitch It and Rasmus, the famous Rasmus. So, welcome.
Hello.
Hey.
Thank you, Laura.
Hi.
So, serverless, that's an interesting take. What exactly are we going to talk about serverless? I just read the other day, there's an article about Amazon ditching serverless for their Prime Video offering.
Serverless must be dead.
Serverless must be dead, right? Yeah, but I know that, I was actually posting about it in our internal Slack channel, and our CTO, John Mott, who is on the call with us, was passionately against that serverless is dead argument. So, John, what do you really think happened?
Well, I think there's been a lot of kind of like agenda. There's people furthering their own agendas off the back of this post, and kind of what most of them are missing is like the fact that the Prime Video is a really successful product that was built initially really quickly on serverless, and it scaled to the point at which the things that they were trying to do with the product, the architecture didn't support it anymore, and they chose a different solution for this particular service. And I very much think it's a pragmatic decision to go, well, actually, this architecture wasn't working for us in this situation, and we switched it for something else, for the scale that we're at, for all of the other reasons that it made sense for that product. And I think that there's a lot of FUD. A lot of people using it as to further agendas of like, we want everything back in our own data centers. And then on the serverless side as well, a lot of people going, no, they made the wrong decision. They should have built it this way. I don't believe that the team would have not thought about how they could have rebuilt it using serverless in their things there with the experience that they had. I don't think they're a stupid team. And there's this kind of range of serverless to bring everything back in house, and we'll run all our own tin and manage everything. And I think that it's a lot of it is missing the point that this is a pragmatic decision, which is the right thing for the product that they're building and the right thing for the team.
So if I break it down, John, what you're saying is serverless is still a viable technology for a lot of the people who wants to create solutions and do it really fast. It is still a viable technology. And two, you don't have to use serverless for everything. Only if your architecture supports it, right? There are two different aspects that you talked about.
Yeah, absolutely. And that architecture question is I think that's the key one of like making sure you build your architecture, you design to the problem fit that you have. And I think that ultimately the kind of like the serverless or the service full way of building things is a really great place to start, and it's a really great place for many systems. They don't need to migrate or go beyond that. I think there's a hugely powerful kind of systems building paradigm, and it gives you the advantages of focusing on your problem rather than focusing on running all of the underlying systems that you might need to do that. So if you have a problem which fits serverless well, then I think you should embrace it. I think that serverless first mindset makes a ton of sense. But you shouldn't try and force every single problem to be a serverless problem. It just that doesn't make sense either.
I sort of get the impression that serverless might be one of those more polarizing topics, maybe in part because it can feel alien. Like a lot of us are just used to, we used to write things right on computers, and then there were these like VMs that popped up. Now there's like containers, which is like a gradual thing. But then serverless seems like it just came flying in from the side. Like, this is way different. Like, wait, what? There's probably a lot of us, myself included, quite honestly, that just still feel stuck in the old way of doing things. And this is reminding me, because a book you actually recommended, John, the value flywheel effect, I got a similar kind of weird impression from the author that he was just like really big on serverless, like everybody should be serverless first, which was the key point. And he was also expressing like confusion that it hasn't taken on more, which I would link back to that it might just feel kind of alien.
I mean, I still remember the days when I started, looking at Lambda. I mean, the biggest problem I had was, I didn't have a server to work with. I mean, it did make my life a bit difficult initially on, but it doesn't mean that, Lambda is a bad choice. Speaking of which, I know that we internally are using Lambda or other serverless architecture for a lot of the products that we have internally. But before I go into that, one quick question, John, just to confirm. So this move Prime Video did, or Amazon did for the Prime Video offering, it's nothing to do with scaling, is it?
Well, it kind of was and it wasn't in this particular example. So they were struggling to scale their serverless system because the architecture didn't meet the needs of the system at that point. So they had two services which are very, very chatty together, and so that was causing them, that architecture was causing them problems because there was lots of communication between the two things. I think it would have been possible to have put those into one serverless component or done something similar with the architecture, but they chose. I think there was some cost reasons as well to go and use ECS and go for a container-based approach. Because they were at that scale where maybe it was like the cost advantage was there, and they could have that scale. You can have serverless system. I mean, it clearly had scaled to that point, and it's difficult to say whether it is scaled even further. They've made the decision that it wasn't going to, as in that architectural form. So.
Got it. Okay, so if I have a microservice that I'm developing on, I can still do it in serverless architecture, maybe using Lambda, maybe something else, and I can still scale it to a point where it's being used by millions of users. In this particular case, it was so chatty architecture between the different microservices that was causing the issue.
Yeah, very, 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 very much so. I think that's a kind of that's the way I read that article and see the problem that they have.
So serverless is not dead after all. Phew. All right. With that said, as I was saying earlier, internally we use serverless architecture for a lot of our products, and on that account, we have Erko from Stitch It application here. So Erko, welcome.
Yeah, nice to be here. And we also for Stitch It product use serverless, or to be more precise, AWS Lambdas for most of our application stack. I'd say about 90% of the application is just a bunch of Lambdas talking to each other. The only 10% that isn't serverless is just one EC2 that's performing rate limit calculations or just keeping track how many tokens each customer has left.
Erko, before you go into the details, let me ask you this. I mean, were you freaked out seeing this news? I mean, is serverless dead?
No, not at all. I mean, people have opinions, and in my opinion, there is a tool for every job. So if that tool was to run something in a server-full fashion, then that probably served them well. But in our case, being a young product still in beta, getting to leverage serverless has been really, really good experience. I'd say serverless has served us quite well so far. It's not to say that we might be able to scale to infinity with serverless, but right now it's doing its job pretty well.
So what is this product about? I mean, what exactly is Stitch It? Maybe you can tell us what Stitch It is, and then we will go into the architecture.
Yeah, so Stitch It is basically a tool for building integrations in a code-first manner. You can imagine things like Zapier and Workauto and Make that, generally speaking, are low-code or no-code based integration tools. Or you can imagine in the older enterprise on-prem days where enterprises had ESB tools, enterprise service buses, basically, which had both of the coding capabilities usually and some low-code interface. So Stitchit is one of those tools that's primarily code first. The code itself is either JavaScript or TypeScript that you have to use. And it takes care of all the tedious parts about building integrations. So don't have to worry about where your code is being executed. We actually take care of it for you, running it on top of AWS Lambdas under the hood. And we also take care of things like how to manage connections, how to manage authentication, how to store those authentication credentials securely. And then we'd also try to make your developer experience pretty cool by providing an editor which is based on Visual Studio Code. So your developer experience can be quite familiar if you're coming from a background where VS Code is being used.
Quick question: you did mention about using an enterprise service bus for something similar, and that reminded me when I was working on a similar integration product. Years back, we actually went with Mule ESB. Now, question to you: what was your consideration for going to AWS Lambda for something like this, and for serverless architecture in general? Why didn't you use an ESB?
Why did I use an existing ESB? So our first consideration was that we wanted to be a SaaS platform, meaning that you don't have to host something on your own. You don't have to worry about the server where it's running. So that's the first consideration. We wanted to just offer users an interface, a web-based interface, where they can just log in, set up the connectors they need to connect to, with the tools they need to integrate with, and then simply just directly jump into writing the business logic in code. The very same value proposition of Script Runner, if you're familiar with Script Runner, is that instead of building a massive Java-based plugin to enhance the Atlassian applications, you can just install Script Runner, do a little bit of configuration around where you want your scripts to be run, and just write your script.
Right.
Very interesting.
So early on, I was also thinking a little bit like if this whole Amazon thing is really more of almost like a cost optimization thing. Like they started out, they moved fast, they broke things, they got cool things working. And then later on, they realized, hey, these two services are kind of chatty. Maybe we should turn them to something else. Have you encountered anything with Stitchit where you can sort of guess at, hey, in the future, maybe there are some bits that we're not going to be doing serverless?
Oh, yeah, definitely. If there are cost considerations, if there are performance issues that arise from serverless, if there are scaling issues, because serverless can scale, but you still have to be aware of, in case of AWS Lambdas, your AWS account limits. And there are certain limits that you cannot go over. And if for some reason that doesn't work for you or it doesn't work for us, there's no point. We won't be sticking to serverless if we have an alternative route to, let's host it ourselves and probably be more efficient in the progress.
We spoke about cost in general. I mean, when it comes to Amazon doing it, or even you are talking about cost considerations, that, I mean, for some of the listeners, it might actually pose this question. So are we really saying that Lambda or serverless architecture in general is, will cost us more than using containers?
I'd say on contrary, it tends to cost less because, again, speaking about AWS Lambda, can comment on Azure Functions or Google Cloud, similar things. You pay for the execution, meaning that if there is no traffic, you don't pay anything. You only pay for the stuff that you're doing. When you take a container or EC2, then you're paying for on hourly basis how much that or for how long that EC2 is basically running. So in a lot of cases, you can be far more flexible in your cost optimizations with serverless.
That is exactly the point I wanted to clarify, because in many cases the number of executions might be quite less, and what you'll be doing by running an EC2 instance is you're paying for resources that you're not actually using.
Yeah, I think one of the really important, particularly like business applications, and is like the scale to zero aspect of serverless is really, really important. If it's not being used, costs you nothing. For a lot of applications in the thing there, so it works really well for infrequent things or bursty product tools or services that you might have, which is, I think that's one of the key advantages that it has over a container-based system.
I have actually seen a lot of the cases where there are issues about startup times. Like, for example, if you're running Java runtimes, it takes a bit of time to start it up. Is that going to be an issue? I mean, have you seen any issues like that, Erkko, with Stitch?
Cold start in generally, I would say, or call an Achilles heel of serverless. And cold starts, regardless of the runtime you use, is a thing in serverless. You kind of have to factor it into your architecture. Java, yes, is more heavy than let's say like a Node or Node.js that we're using. But for example, AWS has done some pretty interesting optimizations around Java. I believe they have a feature called Snap Start or something that is supposed to create a snapshot of JVM and basically serve it when you want to go, skipping some of the regular startup execution. But yeah, generally speaking, half a second is something you have to encounter into some of the requests that are stored from a cold start. And usually this is something that, when your application gets hit, you usually have a bunch of lambdas that talk to each other. Worst case scenario, all of them are cold, so you multiply it by half a second. But more traffic you have, mathematically speaking, less chances there are for a single user to hit all of the lambdas in a cold start, because chances are that you will be hitting a lambda that is already spooled up. And even then, AWS gives you a bunch of tools to mitigate this issue, which one of them is provision concurrency, which is pretty much like an EC2. You basically pay AWS in advance to keep those lambdas warm for you, and every request that can fit into that spool of warm lambdas will be served from that pool of warm lambdas. And if it doesn't fit into that pool of lambdas, then obviously you have to suffer the cold start.
Seems like more bits about just, fitting your business. Like, what do you do? What is your pace? How much do you scale? Do you get quiet?
Yeah, if you want to do some black box trading where latency is really, really, important, algorithmic trading, then you probably don't want to run them in a lambdas. Having half a second delay buying a stock at the price you wanted to pay is probably not going to be good enough for you. But in a lot of business applications, couple of half a second here or there occasionally probably won't move the needle too much.
Yep. I ran into a similar kind of comparison myself not that long ago, because I'm a big fan of Google Cloud and so on. And I was building a new Kubernetes cluster, and I realized that, oh, wait, GKE Autopilot is a thing now, which is where that Google will keep the nodes, warm or whatnot for you, but you don't maintain a cluster. You can scale to 0, even though it's Kubernetes. But while that sounds like you'll be, I like that, because then I don't need to pay for the resources I'm not using, then there's the little gotcha that, wait, no. When you actually run a thing, you get charged for the entire resource requirement, request you've put on your stuff. You don't get to take advantage of I've got 10 things running and they're all running at 10%, so I only need 1 unit of something. So there's always some way they're going to get you.
Yeah, the details are in the fine print usually.
Yep. So the one other thing I was curious about cost-wise that has kept me away from using something in the past is Zapier or whatever it's called. Because I was looking at, open sourcey hobby things like, hey, this thing looks kind of useful, but I only get 100 saps a month before it starts costing money and so on, which may not be a lot, But when you're trying to do something for free, you get scared of these kinds of limits. So I never really got into using Zapier, but now it feels like with Stitch It, we have sort of like our own thing. And now I'm thinking about all these cool, neat ways that, hey, now that I have an in, I want to use this stuff.
Yeah. Usually these tools have a free tier. These free tiers are quite limited. We also have a free tier. Currently in the beta, it's quite generous. We give you 10,000 function invocations per month. Just to clarify what is a function invocation. So basically any function that you need to run in our platform, any external event that you need to process as part of your integration logic is basically one function invocation. So yeah, you should be able to actually do quite a lot within those limits.
That sounds more generous than the Zapier thing. Can you perhaps do a bit more of a contrasting thought on like what would I use Zapier for and what would I use Stitch It for?
So Stitch It, because it's code-based, is aimed at solving more complex integration issues. Zapier, on the other hand, is primarily no code first. You start out with the UI. You set up a bunch of actions in your SAP. By the way, I haven't really used it, so please forgive me if I get the terminology wrong.
That sounds about right, yeah.
And you're supposed to be able to do simple things really quickly with Zapier. But the thing with most of the low-code integration or automation tools is that you will hit the ceiling pretty quickly in terms of complexity that you can do. Some of them address it around the fact that you can have an escape hatch into the code in that tool also. But our unique perspective into the solving integrations is that will give you code from the start. So you can do your simple stuff in the code and the most complex stuff in the code also. So you have this one single unified and optimized interface around writing code and all the things that have to happen around that code to run integrations properly, such as connectors and other things.
Yep, that sounds quite reasonable. I have hit the wall with Zapier, just thinking like I want to do a thing to Trello, but the right thing isn't there, so I can't do it. But I guess I can do that with Stitch It then. Yeah,
there are only two requirements when it comes to connecting Stitch It to something that you want to work with. Is first, can you connect to it? Stitch It is a SaaS product hosted in cloud, in the internet. And if you have something behind the firewall, then you can't really hit it. But what you can do is we offer a static IP address, and you can add a firewall bypass rule into a firewall to let Stitch It connections pass through. Or you can set up a reverse proxy in some of your DMZ networks if you want to, do it in a slightly different manner. So you have to do a little bit in your network security to let Stitch It connect to your service. And the other requirement is that the thing you're talking to has to have some sort of HTTP-based API available to be able to talk to it. Usually, REST API, GraphQL, whatever works over HTTP, you're good to go.
So I'm going to add a few use cases to it, right? I mean, obviously, you talk about integration. I have worked on products which integrated. I remember Jira with Quality Center, because at some point, a lot of the folks were using Quality Center, HP ALM for test case management, whereas user stories were written in Jira, and they wanted to keep them in sync. So, you know what's happening on the test case management side inside Jira itself. And we had written integration platforms to connect Jira with Quality Center. I could potentially say the same thing with Jira and GitLab these days, right? I mean, in Jira, you do user story management. In GitLab, you're hosting your code, doing CI/CD, a lot of the things, but they also have an issue tracking inside. So I can keep the issues in sync between Jira and GitLab. Just two examples. So what you're saying is Stitch It will work with any of these tools if I want to integrate them together. Did I get that right?
Exactly. And in regards to Jira and GitLab, those are the two tools that we have officially connectors available for. The difference of having a connector and not having a connector is that if you have a connector, It's really simple. There's a UI, you go through setting up the connection, and you basically then start editing APIs. If you don't have a connector, then we offer something called a generic connector, which means that you have to put your API keys directly in there as one of the headers that have to be passed along. It's a little bit more less user-friendly if you don't know exactly what you're doing, but you still can use this as an escape hatch into the tools you need to work with. But in your case, GitLab and GitLab issues or tickets or whatever it's called there, syncing it with Jira on-prem or cloud should be actually quite straightforward with Stitchit. You still have to write the business logic on your own. When something happens in Jira, then what happens in GitLab and vice versa, if it has to be bidirectional. But connecting these two tools should be quite straightforward.
So connectors are really kind of like the existing integrations in something like Zapier.
Connectors are really not existing integrations, but gateways or interface into talking to certain tools. The integration, well, it depends what you consider an integration. I tend to look at integration as the business logic that actually moves data between those things. But obviously, part of the business logic is the connectability. Those two tools have to be connected. And the great thing about Stitchit compared to maybe some other tools is that it's not designed to be one-to-one, let's say, facilitate one-to-one integration, meaning that something happens in system A, then do something in system B. You can do many-to-many. You can have, let's say, listening events from 3 different Jira instances and bumping them to 2 different GitLab instances based on your business logic. That's the flexibility you get with Stitchit.
I have actually seen the demo for Stitchit, which gave me some more insight into how these connectors work. So having a connector, obviously, it helps you get up and running really fast. But don't you have something called Manage APIs, which will help you code that business logic faster?
Yeah, we have the concept of managed API, which basically is a wrapper over the underlying API. Usually they are either REST APIs, usually currently it's only REST APIs. We are looking into how to kind of abstract away the complexities of GraphQL, also give you a little bit simpler interface. But the idea is indeed that instead of you having to know how to call that API, which usually means what's the URL, what's the method of HTTP request, what's the payload of the HTTP request, and what's the shape of the response that you're getting back. What Managed API is doing is basically telling you exactly what you have to do. Instead of you having to know the URL, you just call a function as in a regular programming language. And what it under the hood is doing, it's basically calling that API endpoint for you. And it's going to tell you what are the parameters you can pass along, what is the shape of the body or a request that you can pass along, and also what's the shape of the response. So you don't necessarily have to even look up that information from the external documentation. We try to keep it up to date for you.
So it essentially brings down probably the code from, say, 100 lines of code to maybe less than 10.
Yeah, it definitely reduces the number of lines of code and also cognitive overhead in terms of you having to know all of these details. Because when you use it in our editor, you get the code successions and auto-completions when you're working with these APIs. It doesn't remove the need to know how this tool works. In Jira, you have issues. In GitLab, you have something else. You have to know that how these things are called. So the business logic stuff is still for you to figure out, but it takes care of working with APIs is just slightly more manageable.
So I'm kind of curious if we are past this topic. You're working with a serverless heavy application. One thing that's always kind of made me wonder, like make it feel alien, is how do you have a healthy dev and test cycle with serverless? How do you have the developer experience of, well, I want to add a new connector for like Discord. Do I go in a branch? Do I go in a different serverless URL? What do you change around to just, not impact your live service?
It depends. I guess it depends how teams have figured it out. The way we have figured it out is actually pretty simple. For each of the developers, they have their own AWS account, and everything we have is written in all the infrastructure is managed by CDK. So we basically, each developer deploys their own stack and develops it against that stack. And when things are ready to go, they basically get through a Bitbucket pipelines, get deployed directly into staging and production AWS accounts.
That's very interesting, because earlier we talked about the cost, and you don't have to really worry about each people running their own AWS accounts, because you're basically only paying for the executions. You're not paying for EC2 instances running forever for each developer, right?
Generally speaking, yes, except the one EC2 instance that we have, which we are paying full time. But generally speaking, that's true. If the instance doesn't get any load, or the account that's backing it, then the cost is actually quite low. But generally speaking, serverless is just one piece of the puzzle when it comes to developing a product. You need other AWS services there also, and some of them do get charged differently. For example, you may want to have some SSL certificates for your hosting somewhere, and that gets charged differently. For example, we have also a VPC network, primarily to put that EC2 into secure network, but that EC2 interface, the VPC interface itself gets charged on hourly basis. So there's definitely cost reduction, but it's not zero. It's just less.
So you mentioned a staging environment. That one has its own like permanent URL. You can have other things tied into it and so on.
Yeah, it's a carbon copy of the production basically.
And then essentially, if you try to do a new connector, you'd probably just do everything over in staging. Or would you ever have a point in time where you're doing one thing in staging, but you're pointing at something in production?
No, staging is primarily just there to currently, it doesn't really serve a purpose. Everything goes to directly to production also, but ideally there should be a bunch of end user tests that have to be run there to verify if you didn't hit any regressions or anything as part of the deployment. But staging is really to verify if it's safe to deploy to production. In this case, when it comes to, for example, developing a new connector, let's say I have a developer somewhere that needs to do it. They have their own local AWS account where the local stack is set up. They basically just go ahead and create a new service that deals with that particular connector, deploys in their local stack, tests if it works properly. As part of the PR review, they can also expose their own URL for that particular development environment. The rest of us, we can just log into that developer's instance and test that connector. If it looks good, we'll give a thumbs up. If not, then go back and fix something.
Okay. So that got me to one more question, which is, can you do automated testing with all this stuff? Can you have a test suite for different connectors and how they might work with each other?
Yeah, we actually do. Actually, from front-end perspective, from the user's perspective, how to set up a connector, we have a bunch of end-to-end tests written in Playwright that just, presses the buttons that automatically that the user would otherwise would do.
Cool.
So it does look like serverless is not dead based on the conversation. And I have no plans to kill it either, but I do have to ask about one more limitation because I think I was, for one of our customers, for the engagement, we were considering Stitch it for bulk migrations. And one of the limitations we came across was Lambda itself has limitations in terms of how much time it can execute. A single Lambda execution can take. I think it was like 5 minutes or something. And 15. That was 15 now? Okay.
always has been 15 as far as I remember.
15. Okay. All right. I'm wrong. 15. I'll go with the expert here. But that limitation did actually pose a problem for us because, some of these migrations can go much, much longer than that. So how do you work around limitations like that? I think for integrations, it's probably not a problem because you probably wouldn't see a single thread running for more than 15 minutes. But
So that's a very good point that Lambdas have limitations, and because Lambdas have limitations, we pose that limitation to our end users also. At least as long as these user scripts are running in a Lambda. One example is if you want to get rid of a Lambdas, we can start hosting our own containers where those scripts are running. So one way to get rid of that limitation is just not to use a Lambda. But migration is a very interesting topic because we actually are kind of solving this problem with Stitchit for some of our users. And yes, there is this 15-minute limitation. You just have to work around it. And Stitchit actually gives you tools to work around it. And coincidentally, I'd argue that forcing somebody to work around this limitation makes your migration script far more reliable. So let me explain the way we work around it. But before I explain it, I'll tell you about the script that we have currently in Stitchit. And so one of the tools we support is a Tempo worklogs. It's a tool in Jira ecosystem or Atlassian ecosystem for logging worklogs. How many hours somebody worked on a particular ticket. And as of today, Tempo doesn't have a bespoke solution to migrate workloads from one cloud instance to another. So they came to us and asked, can we solve this problem for them? And we did via Stitchit. So we built a bunch of templates. A template in Stitchit is basically a blueprint, a full complete solution that you can basically create your own workspace from. A workspace in Stitchit is basically where your integration is set up. All the code is there, all the connectors are configured there, everything is in a single workspace. And so we have a bunch of migration templates. We have one for Tempo accounts, one for Tempo worklogs, and the most important one is the worklogs. Those are the ones where people may have millions of worklogs in a single instance that needs to be migrated. And the workaround is so that when a script starts running, it basically starts tracking where is the progress, what have I done previously. And it continues where it left off previously. So it starts doing this thing. It monitors when it's about to run out of time. So it's about 14 minutes is the limitation we've set. So 1 minute just for the safety. And when it's about to run out of time, it restarts itself. It programmatically says, okay, so I want to start a new script execution basically. So and the script basically runs in a loop. And every time it starts off, it checks how many worklogs I managed to migrate previously, and it then continues with the worklogs that it hasn't migrated so far. But the consequence of this thing is that you can pause this migration at any time because the state is stored in Stitchit using something we call a record storage, which is a simple key value store. And you can resume the migration at any given time because the previous state is there. It knows how much stuff it managed to migrate, and then it just continues where it left off. So that's an example of finding a workaround of a hard limitation that that AWS currently forces us to comply with.
I think this is a really interesting example of where the architectural constraints and limitations actually push you towards a more robust or better design. And I think there's plenty of examples throughout, like serverless and like API Gateway, Lambda, SNS, SQS, those kinds of tools which push you towards more resilient architectures or potentially more scalable architectures due to those constraints. So yeah, I don't know if you've got any kind of thoughts along those lines, because it's something that AWS pushes as a good thing about serverless is that it squeezes you more towards good quality, well-worn architecture.
Yeah, there definitely are limitations that we ideally want to get around, but that we kind of have to deal with them. One of the particular limitations is that a response has to be sent back with an API gateway in 29 seconds. Weird number, but it's 29 seconds. And there are plenty of things. Well, one thing is that you should make sure that whatever the process that you're running behind an API gateway responds in a flashable manner, because if you go above 29 seconds, well, you get an error back basically. So yeah, I agree that those limitations actually make you write the more robust solutions.
I understand the point. I mean, limitations are there for a reason, and as John said, maybe it is in our best interest, so we can make our architecture a bit more robust. But I can't help ask a controversial question here. Is this one of those cases where maybe serverless is not the right fit for the architecture that we have? Should we be looking at something else? So you don't have to work around the limitations, but instead maybe there's a better solution out there which we can use.
I'd say it's all about the cost of, how much it costs to re-architect around the limitation versus, okay, so that limitation is just getting in my way, I'll do it in some other solution. What's the cost of that one? So if the cost of, going with something else, then it's a no-brainer.
And the cost of running it for the next 5 years or 10 years.
Yeah, the cost itself is only not setting up the solution and how much it costs on, let's say, an AWS bill of running EC2. It's about, what's the maintenance? When you go away from a Lambda to EC2, you have a server, you have to patch that server, that's time. There's people costs, people have to know how those EC2s work, developers who, have to maintain it, or if you're not doing DevOps, then some operations people. So cost is not alone, just not the cost that you see in the end of the month in your AWS bill.
So to summarize, serverless is not dead. You just use it when you need it.
Exactly.
Reminds me of that analogy where, you can hammer a nail with a screwdriver, but is that the best tool to use? Probably not.
Yeah, you can build a house with a sledgehammer also. Not very efficient.
All right. Well, thank you guys. Thank you, Erko, for coming on and talking to us about Stitch It and the serverless build of it. It was really fascinating. I think we need to do it again. And that's it for the DevOps Decrypted podcast. You can connect with us on social media at Adaptavist and let us know what you think of the show. For myself and John and Jobin and Erko and Rasmus, thank you for joining us today, and I hope you have a wonderful day.